right, today we're going to be looking at Lesson 56 and Lesson 57 in your geometry book. Lesson 56 starts on page 368. And in this we're going to be looking at 30, 60, 90 right triangles. Okay. All right. Hopefully we remember our 45, 45, 90 triangles, right? Okay, we've covered that. Okay, this is similar, okay, except it's different ratios. So instead of 45, 45, 90, obviously we're at 30, 60, 90. So in the 45, 45, 90, it was pretty easy because it was 1 to 1 to 1 radical 2, or easier yet, x, x, x radical 2, right? It was easy because 45 and 45 are the same. It's going to make an isosceles triangle, which means 2 out of the 3 sides are the same thing. Okay, and then my hypotenuse is my side, my leg, times radical 2. 30, 60, 90 is going to be a little bit different than this. And rather than going through a lot of the stuff that's in the book, just real simply, what is opposite of 30? That's my short side. We're just going to refer to that as x. Okay? Let's see, across from my 60 side is x radical 3, and across from my 90 side is 2x. Okay? So that's the information that you want to write down. That's the ratio that you want to know. In order, 30, 60, 90. Okay? X radical 3, 2x. Okay, you need to remember the differences between that and your 45, 45, 90. Okay? On page 368, properties of a 30, 60, 90 triangle. It reads in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the short leg. Your short leg is going to be your side opposite your 30-degree angle. And the length of the longer leg is the length of the shorter leg times radical 3. So what you want to understand is that everything is built around my short leg. Okay? The hypotenuse is 2 times my short leg. My side opposite my 60-degree angle is my short leg times radical 3. The hypotenuse and the side opposite 60 have no direct correlation. It's easy to make. So I always want to go from my 60 back and forth from here, or from my hypotenuse back and forth to that short leg. Okay? All right, does anybody have any questions over that part up to this point? Okay? If you've got that information down, you've got down a lot of what we're going to need for this. So let's work out some example problems before we move on. Okay? Let's dim this page down and let's make a 30, 60, 90. And let's fill in some gaps for this. If I got 30, 60, 90 here, okay? Let's say that the side opposite 30 is 4. Okay, what is going to be my hypotenuse? 8. Okay, because I'm going to take 4 times 2, and that's going to give me 8. What is going to be my side opposite 60? 4 radical 3. Very good. Okay, that's a pretty easy one, because we start with the short side and everything's built around it. Okay, let's try a more difficult one. Okay, slightly more difficult, and we'll work our way up. Let's say that this is 6 radical 3. What's the next thing that I want to find? Not the hypotenuse. The bottom, the shortest leg, right? What is my short leg? 6. What is my hypotenuse? 12. You see now why I can't go from the side opposite 60 directly to the hypotenuse, right? Because I can't get from 6 radical 3 and just understand or just know 12, right? I need to understand the short leg before I can understand the hypotenuse. All right? Let's try a different one. Let's make this 10. Okay, what's the next thing I want to find? Short leg. What's my short leg? 5. And what is my side opposite 60? 5 radical 3. Okay, good. All right, let's try another one. Let's make this just 10. How do I find my short leg? No, it's not 5. what you understand. 10 equals x times radical 3. Now let's solve for my short leg. Short leg is what? It is x, correct? All right, so what do I need to do at 10? I need to divide both sides by radical 3. Okay? Can I leave it as x equals 10 radical 3? What do I need to do? Multiply by radical 3 over radical 3. This is going to give me 10 radical 3 over 3. In our case, won't reduce, right? So, we know that this guy right here is 10 radical 3 over 3. Can I find my hypotenuse then? Okay, what do I need to do with 10 radical 3 over 3 to find the hypotenuse? Okay, multiply by 2. What's 10 radical 3 over 3 times 2 over 1? 20 radical 3 over 3. Okay, trying to get to more complicated questions. Now, this is a really good question to write down so that you can understand it whenever you see more difficult questions show up in your homework. Okay, I can give you a second, but you're going to get this video later on, and you're going to be able to go back and pause it right here and look at this work then. So, for the sake of time, what I'm actually going to do is I'm going to erase this. You're going to go back and watch the video to get this information, right? You're going to nod your head up and down. I don't need to wait, and we're going to be able to move on. All right, let's try another one. Okay, let's say that this is 5 radical 3 down here. Okay, 5 radical 3. What's my hypotenuse going to be? 10 radical 3. Okay, what is my opposite 60 side going to be, or how would I find it? 5 radical 3 times radical 3. Can you tell me what radical 3 times radical 3 is? 3. So I'm going to get 5 times 3. So what is my side opposite? 15. Okay, my answer here is 15. Okay, how many of us feel pretty good about this? We've done enough different question types that if I had to do my homework and all I really needed to do is go back and watch the notes, I should probably be able to get most of these. Okay, most of us feel good enough that we can move on. All right, so I'm going to leave that there, and we're going to go over to lesson 57 and see what notes that we need to make on lesson 57. Lesson 57 is finding perimeter and area with coordinates. So let's make a new page here. Okay. Lesson 57, finding perimeter and area with coordinates. Okay. And you'll notice in here that there really isn't any, there's no definitions, there's really no notes. So I'm going to read this first paragraph. It says, when a figure is on a coordinate plane and no measurements are given, the distance formula can be used to determine the measurements necessary to find the area or perimeter of the figure. A lot of counting, but distance formula. And we can use the distance formula, or we can use the Pythagorean theorem to find lengths of sides. Once I know the lengths of sides, I can find the perimeter. Right? If I know the lengths of sides, I can find the area. What's important to know, let me ask this question, and hopefully you guys can answer this question loud enough that we can hear it on the recording. Is distance ever negative? No, exactly. Okay, distance is never negative. That's important because even though in a coordinate plane are some of my numbers negative? Yeah, some of my numbers will be negative, but that's not affecting the distance. Right? That's why we want to understand the actual distance formula here. That even though it's moved across, it's on maybe the second quadrant or third quadrant or fourth quadrant, those negative numbers are not affecting my area or my perimeter. Okay? All right, let's move into actually answering some questions. Okay? This is a really important question, this number 1 here. Okay, because we're going to see this question show up on multiple tests. Okay, and you're going to need to know how to draw it. The yield sign has a shape of an equilateral triangle. So we need to know some things about equilateral triangles. What do I know about equilateral triangles? All sides are congruent. All sides equal each other. What else do I know about an equilateral triangle? All angles are congruent. Okay? Let's take that specific truth. All angles of an equilateral triangle are congruent, making it an equiangular triangle, which means all equilateral triangles have what angle measures inside? 60. How did you know that? Right, because all triangles have 180 degrees, and if all angles are the same, then we take 180 divided by 3. So all angles of every equilateral triangle are 60 on the inside. Okay? So I'm going to have you hold on to that information right there. We're going to move over here to a blank page so that we can see this drawn out. Okay? We want to draw a yield sign. Should look something like this, right? We've got enough drivers in here that can recognize a yield sign. I don't know, I've seen some of you drive. Maybe you don't know what a yield sign looks like. All right? It's not a stop sign, but it does mean to yield, okay, for oncoming traffic. So let's go ahead and input the information that we know. We know this is 60. We know this is 60. We know that is 60, right? Okay? Let's see. We know that the yield sign has a shape of an equilateral triangle with a side length of 36 inches. So I can make each side here 36 inches. Now, the question that they're asking is that we have a rectangular sheet of metal. We're wanting to cut out as many yield signs as we can. And it says, what is the height of the sign? Will a rectangular metal sheet that's 36 by 32 inches be big enough to make one sign? All right, so let's imagine that my sheet of metal is this green part right here. I'm going to make it across. Is it being 36 by 32? Do we know that it's going to be wide enough? Is it going to be wide enough for my sign? Okay, so I'm going to come down here. Okay, the question is, okay, if my green sheet is 32, and I'm not making this necessarily scale, our hope is this, okay? Our hope is that 32 inches width-wise is going to be enough. What do we actually have to solve for on this triangle? The height. I need to know what is this length, okay? And that line right there is called the height of the triangle. And what it's going to do is it's going to cut this length there into two congruent segments. It's also going to bisect this angle right here. All right? What is half of 60? 30. Okay? So that's a 30-degree angle. Okay? Which means what is this side right here? If the whole length is 36, and that line, that altitude counts as an angle bisector, an angle bisector, and it's going to cut that into congruent segments. What is this length here? 18. Okay? And we know that this length here, from here to here, is 36. All right? We need to find, let's use a different color so you can see a little bit better. We need to find that red line. And how do I do that using what we know about 30, 60, 90 triangles? Gradient. You can use the Pythagorean theorem. Okay, but let's use what we've learned today. All right? In fact, I'm going to take this triangle, and I'm going to flip it. I'm going to pull it out here. Okay? We said that this is 18. We said that this is 36. Right? Here's my 30. Here's my 60. All right? Can I know what that is? What is it? 18 radical 3. Okay? Is there any way of plugging that in to a calculator and finding out what 18 radical 3 is in inches? Okay, can I do that? What is 18 radical 3? $31.17. Well, let's just round that up to 31.2 inches. Okay? Is 31.2 inches shorter than 32 inches? So do I have enough metal to make my sign? Okay, so this is the answer that we needed in here. We needed to find the height was 31.2. You would not have been wrong if you had done the Pythagorean theorem. so long as you set it up right, you're getting 18 squared plus b squared equals 36 squared. You're still going to get 31.2 inches, but I just want you to see this is actually quicker than using the Pythagorean theorem, okay? And that's what really math does, is that yes, we can solve questions the old way, but the more that we learn, the quicker we can solve these questions. So if you'll memorize those 30, 60, 90 ratios, right, it makes 18 radical 3 a whole lot faster than, okay, what is 18 squared, what is 36 squared, and I've got to square root this. It shortens the number of steps I actually have to do. And the fewer steps I have to do to solve a question, the less likely I need to make a mistake. All right, do we understand that question? Good. Let's get that out of the way. Come back to here. Question number 2. Find the area in the perimeter with vertices -3, 0, 3, 4, 5, 1, -1, -3. Let me see if I still have my, hopefully I still have my coordinate plane here. Let's see, I want to clear that out. All right, let's make a new coordinate plane. Maybe you can make one on your own paper if you want. You should probably practice doing this. Okay? Something that looks like that. A is -3, 0. Now, just as a refresher, -3 means I'm going to go where from the origin? To the left, 3. Right? Alright, so I got 1, 2, 3, and 0. So I'm just going to make my point right there. That's my A. B is 3, 4, so it's going to go to the right 3. 1, 2, 3. 4, 1, 2, 3, 4. Okay. So I got A, got B. C is 5, 1. 1, 2, 3, 4, 5. 1. Okay, there's C. And the last one is -1, -3. Back 1, down 3. 1, 2, 3. Okay. Connect these. Now, if those have been nice, neat, horizontal and vertical lines, this would have been pretty easy to find my perimeter, right? Perimeter and area. What do I need to do? I need to find distances. Now, we can go through the process of using the distance formula given our coordinates, correct? Right? In fact, let's go ahead and write up what the distance formula is, because I'm sure some of you have already forgotten, so you wouldn't even know how to. All right, what goes under that square root? X sub 1 minus x sub 2 squared plus, okay, that's what I want to do with my coordinates. Okay, I can find the distance between any two coordinates given that. Okay, I'm going to try to make this a little bit quicker by using the Pythagorean theorem. Okay, that's, I view that as just an easier method, a little bit quicker. This has me going up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay? 4, 6. Okay, AB is Pythagorean theorem, 4 squared plus 6 squared equals c squared. 4 squared is 16. 6 squared is 36. Okay? 16 plus 36. What is that, 52? Okay, it's going to give me the square root of 52. C equals square root of 52. Okay, let's see if B and C use the same dimensions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, is it going to get the same number for that length? Because it's using the same number for that right time. So square root of 52. Okay, let's check my spot here. Looks like I'm going to go down 3 over 2. Okay, so 3 squared plus 2 squared equals c squared. That's going to be 9 plus 4. 9 plus 4 is 13. So I need the square root of 13 equals c. So that's square root of 13. All right, we go over 1, 2, down 3, 2, 3. Does that have the same dimensions on that side? So square root of 13. Okay, what I'm going to do is I'm going to actually see if I can simplify the square root of 52. Okay, square root, let's see, 52. What did I divide 52 by? Something small, let's try to find 2. Okay, what's 52 divided by 2? Is that 26? 26. Then what's that going to be? 2 and 13. So square root of 52 actually simplifies to 2 radical 13. So I can actually change both of those to 2 radical 13 and 2 radical 13. That makes finding the perimeter a little bit easier because now everything is in terms of radical 13, right? Perimeter then becomes 2 radical 13 plus 2 radical 13 plus 1 radical 13 plus 1 radical 13. What's that going to come out to? I got what? 6 radical 13. Okay, you follow me? Okay, 6 radical 13 is going to be my perimeter. Now let's see if we can find area. How do I find area of a rectangle? Base times height or length times width, right? So what am I multiplying here? Good job. 2 radical 13 times radical 13. Okay, well 2 times 1 is 2, right? Because there's a 1 there. What's radical 13 times radical 13? So what's 2 times 13? So area equals 26, and I'm giving you anything there, it's just units squared. Okay, so this is actually a really good question for you guys to see in terms of how do I find perimeter and area based upon a coordinate structure where it's not nice, neat, vertical and horizontal lines where all I have to do is count blocks, right? Okay, so again, this is a really good video segment to go back and watch, okay, to see how to solve some of these things. All right, let's go back to our lesson here. Number 3, find the perimeter of rectangle QRST with coordinates, okay, such and such. Same basic concept, although 3 and 4 are going to be a lot easier. Actually, 3 is going to be horizontal and vertical lines. You guys are going to work out number 3 on your own and check your answer key for that. You're also going to do number 4 on your own. Again, it's horizontal and vertical lines. Should not be all that difficult to do. So you're going to do that on your time. I'm going to move on to question number 5. Okay, question number 5. Because question number 3 and 4, those are basically rectangles. Okay, let's look at something that's much more complicated in number 5. In the diagram below, find the area in square units of triangle PQR with right triangle PQ, or with right angle PQR. Let's see. Okay, this is confusing. Okay, so this really shouldn't. It says PQR, it says angle PQR. Obviously, that's got to be a typo. Why is that a typo? Give you a chance to look at it. And it says angles ABC, there is no PQR in there, so there's this typo on the test generations part. Alright, so that's really not too handy for us. But let's go ahead and see what it is that we can do anyway. How do I find the area, because that's what it's asking for, how do I find the area of a triangle? What's my formula? And here it says base times height divided by 2. Now, I'm going to try to help us out here a little bit. The angle B should be my right angle. That's that angle PRQ that they're talking about. Okay? So, with that being said, we need to find a base, we need to find a height. We're going to do just like what we did in the other question. Okay? What segment do I want my base to be? Do I want it to be CB, BA, or CA? CB, okay? It's fine. All right, so I need to find the length of that. Okay, so what numbers am I going to use for that right triangle? 1 over 2. All right, so I've got 1 squared plus 2 squared equals C squared. Okay, what's 1 squared? 1. 2 squared is 4. Okay, so I get 5, or C equals what? Square root of 5. Okay? So my base is square root of 5. Okay, if I'm using CB for my base, what length is going to represent my height if I know that CBA is my right angle? What side is my height? AB. Very good, Matt. Okay, so this is my height, so I need to find that length. Okay? So, I'm simply going to go over and down. What numbers are going to constitute my right triangle for my back diagonal here and there? 2 and 4. Okay? So let's come over here. That gives me 2 squared plus 4 squared equals C squared. Okay? 4 plus 16 equals C squared. What does C equal? Square root of 20. Okay? Square root of 20. Let's simplify that if we can. 20 will divide by 5. Okay, leaving me with 4, 2, and 2. So what's the simplified radical form of radical 20? 2 radical 5. So this is radical 5 times 2 radical 5 divided by 2. Okay? What is radical 5 times 2 radical 5? Think about it more. What's that? 2 times 5. Okay? 2 times 5 is 10 divided by 2 is 5. So my area is 5. 5 units squared. Okay? We're going to erase this. You can pause there and look at that as much as you want. I'm going to clear that and move on to number 6. We're going to come back to a 30, 60, 90 question. Notice that opposite of 30 is 12. So what is x? Minor? Well, x is across from the 60. So how do I find the length of x? If you need to, I can... No, you're thinking of something else. Caleb? 12 radical 3. Because x is opposite 60, 60 is x radical 3. So 12 represents my x. So, and I know that's going to be confusing, but we're going to take my short side times radical 3 to get the side that's opposite 60. Okay? I think you were thinking in terms of y. Y would be what? Okay. Y would be 24, which is 2x, so 12 times 2 is 24. Okay? So I want to get 12 radical 3 equals x, and y equals 24. Okay? Let's see, let's look at question number 7. Okay? A flag is in the shape of an equilateral triangle. Each side measures 26 inches. What is the area of the flag? Give your answer in simplified radical form. This is much like question number 1. Okay? So please can draw this upright. Right? What do I know? If I'm asking for the area of this triangle, I need to know my area of the triangle formula, which is base times height divided by 2. Each side measures 26, so we can write 26 all the way around this. Okay? So we know what number can I use for my base. Anybody? What's going to be the base of this triangle? No? Ultimately, so I'm ultimately going to be trying to find the area. 26. Okay? What do I need to solve for here? Height. Okay? So that would be this line right here. What's that line going to do to the base? It's going to bisect it. Okay? So I know that this length right here is going to be what? We know that's going to be 13. Do I know my angles? What is this angle right here? 60. What is this angle up here? 30, because it bisected it, right? So if I know that this is 13, and this is 26, what is my height? 13 radical 3. Awesome. 13 radical 3. So I am taking 26 times 13 radical 3 divided by 2. Okay, what's 26 times 13? 338. So we need 338 radical 3 divided by 2. Let's see, what's 338 divided by 2? 169, radical 3, okay, and that's in units squared. You'll notice you say, well, why isn't this one a decimal? Because it said in my instructions, give your answer in simplified radical form. Okay? All right. Got about 5 minutes. Let's see if we can answer these next couple of questions. Okay? This one says find the perimeter. Okay, it's important to answer the question that's being asked, not just find X and Y. Let's see, Darian, if this side is 15, it's opposite 60, can I find X? How? Okay, I think you were right the first time. X radical 3 equals what? No, it's just 15. Divided by radical 3. Okay, we want to simplify this or rationalize our denominator. Okay? What do I get there? Divided by 3, will that simplify? 5 radical 3. Okay, so what we're saying is that X equals 5 radical 3. All right, I think you're on the right track. Now, Darian, I'm going to come back to you. What would I need to do to find Y? 2X. So in this case, that's 10 radical 3. 5 radical 3 times 2 is 10 radical 3. What do I need to do now? I'm not done. I solved for X and Y, but what's the question asking me to do? What's that? Find the perimeter. Okay, find the perimeter. All right, how do I do that? Add up all the sides. So 10 radical 3 plus 5 radical 3 plus 15. Well, what's 10 radical 3 plus 5 radical 3? 15 radical 3 plus 15. Okay? And that is simply feet. Okay? All right, 15 radical 3 plus 15 feet. Okay? Number 9, I'm going to give you the answer to. It is very, very similar. You're going to get something similar to that rectangle that we did before, except this one's going to look a little bit, in fact, it's going to be a square. You're going to use coordinate paper to solve that. You're going to use Pythagorean theorem to find side lengths. You need to find the perimeter there. Give your answer in simplified radical form. You're going to see that answer in the answer key below. Okay, if you have troubles with it, email me. Okay, let me know if you can't find your answer. Okay, but you want to go back and review that question. I believe it was question number 2. Review question number 2 after you've plotted those coordinates. Okay, in terms of how to find side length. All right, are there any other questions before we close today? All right, great. That's been awesome. Make sure you get your homework done for tomorrow.